1. All right. What's up, guys? Nick Lowe here. Back at it again with the math bit. Standard form of a circle, starting 1.02 conic sections, is going to be x minus h squared plus y minus k squared is equal to r squared. So if you can, write smaller than I can, put it all in one line. But that's the standard form of a circle. So what to remember? HK is the center. HK is the center. So remember, because you have x minus h and y minus k, the coordinates, you're going to flip the signs for whatever term is in your x parentheses and your y parentheses. And r is equal to your radius. So if you get a circle in standard form, take the square root of what's on the right side of the equation to find the radius, and then switch the signs of the x term to get the x coordinate of the center, and switch the signs of the y term to get the y coordinate of the center. Another thing to remember is how to convert to complete the square. So to complete the square, and so for example, let's say you have x squared plus 3x equals 5. In order to get into this x minus h squared form, which is necessary to find the standard form circle, you need to complete the square. And what you do is you take that 3, you divide it by 2, which is going to be 1.5. And so it doesn't always have to be a nice number. Then you square it, and then 1.5 times 1.5 should be, and we can double check with the calculator. No. 1.5 times 1.5 is 2.25. So that could be x squared plus 3x plus 2.25 plus 2.25. And so when you complete the square here, this would factor into x plus 1.5 squared is equal to 7.25. And so that's just an example of completing the square, which is a tool that you'll need to do to convert from the general form of a circle to the standard form of a circle. The next shape is an ellipse, okay? The standard form of a horizontal ellipse is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And if you have a vertical ellipse, your standard form will be y minus k squared over a squared plus x minus h squared over b squared is equal to 1. So as a reminder, a is greater than b, so the larger denominator determines what type of ellipse it is. If the larger denominator is under the x term, it's a horizontal ellipse. If the larger denominator is under the y term, it's a vertical ellipse. Once again, HK is the center. Remember, that's a squared. A is the semi-major axis. Two A is the major axis. B is the semi-minor axis. 2B is the minor axis. All right. The Pythagorean relation for ellipse is that a squared is equal to b squared plus c squared. That's the Pythagorean relation. And that eccentricity is going to be equal to C over A. And I'll just do an example for a horizontal ellipse. But for a horizontal ellipse, the foci would be H plus or minus C comma K. So that's for a horizontal ellipse. For a vertical ellipse, the foci would be H, K plus or minus C. There's more information about the vertices. I guess I'll be comprehensive here. For a horizontal ellipse, the vertices would be H plus or minus A comma K. And that's for the vertices. And for a vertical ellipse, the vertices would be H, K plus or minus A. So that's enough information for now. Oh, wait, yeah. For a hyperbola, their horizontal form, the x term is always going to be positive. So now a squared is not necessarily bigger than b squared, but it's going to be x minus h squared over a squared, this time minus y minus k squared over b squared equals 1. For the vertical ellipse, it'll be y minus k squared over a squared minus x minus h squared over b squared equals 1. All right, so things to remember. Once again, the eccentricity is C over A, and then the Pythagorean relation is going to be C squared equals A squared plus B squared. And otherwise, the hyperbola has somewhat similar features to the ellipse. For the parabola, I think the best formula for you to memorize is so you're going to have a vertical parabola and a horizontal parabola. The vertical parabola is going to have the form y is going to be equal to 1 over 4c times x minus h squared plus k. And for the horizontal, it's going to be x is equal to 1 over 4c times y minus k squared plus h. And in this case, c is equal to the focal length. All right, HK is the vertex. And that if your focal length moves from left to right, it's positive, or up and down it's positive, but down to up it's negative, or right to left it's negative. In general, the focus is always C units away from the center, and the center is at HK. You can get the A and B parameter values from the standard form of the equation, and then use the Pythagorean relationship to find the C value. The C parameter is needed to obtain the eccentricity and the foci. So going back up just for a second. And then going back down. All right. So let's analyze an ellipse for the first problem. According to Kepler's first law of planetary motion, each planet moves in an ellipse with the sun at one focus. Assume one focus, the sun, has coordinates of 0, 0, and the major axis of each planetary ellipse is the x-axis on the cosmic coordinate system. 1 unit equals 1 billion kilometers. The minimum and maximum distances for Neptune are 4.456 and 4.537 billion kilometers respectively. What is the approximate eccentricity of Neptune's orbit? So we need to find eccentricity, and eccentricity is equal to c over a. So let's draw the ellipse. This ellipse will have a focus at 0, 0. And remember, the Neptune is orbiting this focus along the ellipse. So we need to identify, and remember the focus is going to be on the major axis. So this right here will be the major axis, the line that I'm drawing that is dashed. So that value will be the major axis. So that will be the major axis, and the major axis will have a length of 2a. The shortest distance from the focus to the orbit is going to be this length right here. So the minimum distance is, I'm going to call the minimum distance, I'll call that variable A. A is equal to 4.456, and we're just going to stay in billions, so it's going to be equal to 4.456. So this minimum distance right here is equal to 4.456. And the maximum distance B, we'll call it, is going to be, well, actually, these are bad variables here. Just call the minimum distance 4.456, maximum distance 4.537. The maximum distance from the focus to the outside the circle, I'm drawing that right there, is going to be equal to 4.537. Now, one information I can get is that the minimum distance plus the maximum distance is the length of the major axis. So 2a is equal to 4.456 plus 4.537. So I use the equation 4.456 plus 4.537. So that value will be equal to 8.993. So 2a will be equal to 8.993, which means a will be equal to, divide this by 2, 4.4965. Now, while this distance is 2a, and we found a, representing a on the ellipse, a is the distance from the center to one of the endpoints on the major axis. So if this is the center, HK. A will be the distance from the center to one endpoint on the major axis. So that length right there is A. If you notice something, the focus of an ellipse is the distance from the center to the focus. So that distance is A. This distance right here from the center to the focus is C, because C is the distance from the focal length, the distance from the center to the focus. And if you notice on the graph, C is equal to A minus 4.456. So C, just looking at the graph, C equals A minus 4.456. So C equals 4.4963 minus 4.456. So 4.4963 minus 4.456 equals 0.00403. So C equals 0.00403. So eccentricity is C over A. That's what we're looking to find. We found A. We found C. So the eccentricity is going to be equal to 0.0403 over A, which is going to be 4.4963. So I'm going to divide this by 4.4963. And the answer is going to be 0.008. So this is approximately equal to 0.0089, which is approximately equal to 0.009, which is approximately equal to 0.01, making answer choice A the best possible solution. So that was problem 1. Let's move on to problem 2. Suppose a satellite is in an elliptical orbit with the center of Earth as one of its foci. The orbit has a horizontal major axis of 8,910 miles with a vertical minor axis of 8,800 miles. If the center of the orbit is placed at the origin, which equation models the path of the satellite? Okay, so let's look at this ellipse. We have a horizontal major axis of 8910. So that means 2A equals 8910. And if 2A equals 8910, then A is equal to 8910 divided by 2. So A is equal to 4,455. We have a vertical minor axis of 8,800. Okay, so we have a minor axis. So we have two B is equal to 8,800, which means that our semi-minor axis B is going to be equal to 8,800 divided by 2 should be 4,400. Okay, so we have A and B. if the center of the orbit is at the origin, so let's say the center is at 0, 0, which equation models the path of the satellite? So a horizontal ellipse is going to have the equation x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And here, hk is 0, 0. A is 4,455. So if a is 4,455, a squared can be represented as 4,455 squared. And if b is 4,400, b squared can be represented as 4,400 squared. So the standard form of this ellipse would be x minus 0, or just x squared, over 4,455 squared plus y squared over 4,400 squared equals 1. And that's going to give us answer choice B. All right. So that's problem 2. Let's move on to problem 3. A parabolic satellite dish is modeled by the equation y is equal to 1/12 x squared and is measured in feet. In order to receive optimal signals, the satellite company must construct the receiver to be the focus of the parabolic dish. How far from the vertex of the dish should the receiver be placed? So we need to find first the vertex, then the orientation of the parabola, then we need to find the focal length. Okay? So remember, the standard form for a vertical ellipse is y is equal to 1 over 4c times x minus h squared plus k. Looking at this equation, we can rewrite it in standard form of their equation in question as y is equal to 1 over 12 times x minus 0 squared plus 0. So our center is 0, 0. So hk, that's going to be 0, 0. Oh, go. All right, so the center is 0, 0. And our focal length, remember c is our focal length. So if 1 over 4c equals 1/12, then that means 12 is equal to 4c, which means that c is equal to 3. So now we have a vertex at 0, 0 and a focal length of 3. So we go 3 feet, and then we have our focus, and then we have our parabolic dish. So it's not a trick question. If the receiver is placed on the focus of the parabola, and the focus is 3 feet away from the center, and it's the distance from the receiver from the center, or the vertex, the answer is 3. All right. What type of conic, so that's question 3. Question 4, what type of conic is graphed by the equation 4y squared minus 2x minus 16y is equal to 13 plus x squared? All right, so I'm going to fully isolate this conic and then point out how you could solve this question a lot earlier. this question is going to be 4y squared. I'm going to isolate it into 4y squared minus 16y minus x squared minus 2x equals 13. My next step is to factor out the 4, because in order to complete the square, I need to factor out a 4. So I'll have 4 times y squared minus 4y minus x squared plus 2x. Minus x squared minus 2x equals 13. So now I need to complete the square here. So here I will have 4 on the outside, and then y squared minus 4y plus my complete the square term. I'm doing this to get this into a perfect square trinomial. Minus x squared minus 2x plus my complete the square term is equal to 13 plus both complete the square terms. So this is complete the square term x, complete the square term y, complete the square term x, complete the square term y. Complete the square term for negative 4. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. All right. Then negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So this will factor into 4 times y minus 2 squared minus x minus 1 squared. And that will be equal to 13 plus 4, which is going to be 13 plus 1 is 14, plus 4 is 18. You then have to divide each side by and I guess that's going to be 4 times 4. Because you're adding a 4 times 4. So that's going to be 13 plus 4 times 4, which is going to be 16 plus 13 is 26, 29, 30. Okay, so you have 13 plus 4 times 4 is 16 plus 1. So the answer is going to be 30. All right, and then at this point you divide each side by 30. And you'll get y minus 2 squared over 7.5 minus x minus 1 squared over 30 is equal to 1. But this equation is that of a vertically oriented hyperbola. All right, once you see that you have a larger coefficient for the y term than the x term, and then you have a y squared term minus the x squared term, if with enough pattern recognition, you can figure out it's a vertically oriented hyperbola. All right?